My name is Jeff Lewis with the Utah Department of Transportation in the Traffic and Safety Division. I manage the Highway Safety Improvement Program and the crash data for the department. And I am going to be sharing a little bit about performance metrics in UDOT's HSIP program. So Utah is divided into 4 regional offices, and the traffic and safety personnel in each region are responsible for the screening, the concept development, and estimating of a construction project for each HSIP application. So local agencies like cities and counties, they can also submit ideas through the region, through the UDOT region personnel for safety project application development. So here in my group in Central Traffic and Safety at headquarters, we process those applications for safety improvement projects for HSIP. We look at questions like, does the application benefit vulnerable road users? If so, the application gets flagged and we can apply those projects to our state commitment that we've made as a state to dedicate at least 15% of the HSIP funds to vulnerable road user improvements. Those types of projects are like enhancing lighting on roadways or intersections, crossing upgrades, connecting missing sidewalk, dedicated lanes for bicycles or paths or sidewalks for vulnerable road users. And we also, as we're looking at applications, we ask the question, does the application address roadway departure crashes? And if so, we have set aside of HSIP funds to address systemic treatments. And then we look at all other safety project applications. And so that's how we generate ideas. When we process the applications, each application is scored based on its individual benefit cost ratio. And the benefit cost ratio is determined from the highest result of any of the following 3 methodologies that we use. The first methodology that we use to evaluate the potential for a safety project is the 5-year crash history of the crash types that are mitigatable, and the safety improvement can address those types of crashes. And so that's where we use a crash modification factor. Then our second methodology is the anticipated change in the predicted crash frequency of the improvement. It's considered a highway safety model, a highway safety manual predictive model. Then our third scoring methodology is anticipated number of fatal and suspected serious injury crashes reduced based on the USRAP algorithm. USRAP estimated fatal and serious injury crashes reduced. So the benefit cost ratio is calculated based on one of those 3 methodologies, and it's based on our standard list of countermeasures. So then we go ahead and rank all those applications for safety projects. One rule we have is that each application must have a benefit cost ratio higher than 1, a positive benefit cost ratio. Applications are ranked according to their calculated benefit cost ratio. And we allocate money towards the vulnerable road user improvements and the systemic improvements as well. And then the remaining funds are distributed based on the highest benefit cost ratio. Then we award the funds to the most deserving projects. So the ranked applications are awarded until the available funds are exhausted, and awarded projects are placed on UDOT's 3-year plan for HSIP. Once the project is on the plan, the local region can move projects around to make them fit where they best make sense. And applications that do not get awarded are held for the next year's funding cycle. And so next, I wanted to show an example list of applications. So this screen shows just a snapshot of an example list of HSIP projects. There's 9 projects on there from a variety of regions across the state. And then in the middle column, there's the calculated projected benefit cost ratio of what that safety improvement is going to result in. And so the top few projects there are in Region 1, for example. And then the final column shows the estimated cost of construction, or project cost, I should say, that's used to compare to the expected benefit. So some typical example types of safety projects we install with our HSIP program are things like installing raised medians and installing different types of barrier, installing rumble strips, pavement marking and signing, lighting, curb improvements and delineation and warning signs, etc. So that's an example of the types of projects that we work on. The next thing I wanted to shift gears to is the what we use. We call it our story map, and this is basically in the part of the slides I showed earlier where we're helping the region traffic and safety offices identify potential safety projects and give ideas. We, out of MICE Traffic and Safety Division, we developed this, we just call it our roadway departure story map. And we decided, we took roadway departure crashes, and considering that they're our highest crash type, if you will, in terms of highest number of severe crashes, serious injury and fatal injury crashes, by far the highest type of crashes in that category is roadway departure crashes. And so this collection of story maps discusses mitigations, an assortment of mitigations to help address roadway or lane departure severe crashes. So to choose countermeasures to address roadway departure crashes, we focused on proven safety countermeasures. FHWA publishes a list of proven safety countermeasures. So in our introduction page here, we talk about roadway departure crashes, what types of numbers we're dealing with in the state of Utah with severe roadway departure crashes. We link a video that's produced by the FHWA on reducing roadway departure crashes, etc. And then if you jump to the next page, we there's a little bit more introductory information. And what we do is we jump to the first mitigation type, and the first countermeasure or mitigation that we looked at on that proven safety countermeasure list to address roadway departure crashes is rumble strips. And rumble strips, basically this whole page is devoted to rumble strips. There's discussion, introduction on rumble strips. There's the safety benefits of rumble strips, how they're applied on rural roadways. We even have some discussion on the sinusoidal rumble strips. But I want to mainly jump to the safety benefit map because I think that'll be of most interest to the audience here. And so the safety benefit map, this map was developed using a statewide predicted crash model using principles from the Highway Safety Manual. And it was calibrated using 5 years worth of actual statewide crashes. And it ranks based on the safety benefit of a potential countermeasure, in this case, rumble strips. And it ranks based on the safety benefit in terms of reduction in crashes, especially severe crashes, if this countermeasure were installed. And so this map, it displays only the roadway segments on our state highway system that it shows the the segments on our state roadway system that are currently missing some or all rumble strips, whether it's center median rumble strips, left side, right side. They're missing one or more of those stretches of rumble strips on that segment. So the map shows all rural roadways. All rural roadways are included on the map, and some urban roadways that have a posted speed limit of 50 or greater. And the rumble strip data comes from our Utah asset inventory. And so the safety benefit is calculated based on the predicted number of crashes that would be avoided if rumble strips were installed. And the safety benefit is presented in dollars per linear foot of roadway for comparison with the cost of rumble strips per linear foot of roadway. So diving into the map, hopefully you can see that all right. There's the state of Utah, and you see the segments of roadway on our state roadway network that are color-coded by their safety benefit. So over here on the bottom left of the screen is the legend that shows that all the, for example, the green segments are all the segments that are expected or predicted to have a safety benefit of $120 per foot of roadway if rumble strips were fully installed on that stretch of roadway. So if I zoom into central Utah near Price, there's this line segment colored green. If I click on it, it shows what basically the model calculated for this segment of road, which is the total benefit if rumble strips were installed on that segment, the safety benefit, over $2 million of safety benefit in terms of reduced crashes. There's a calculated benefit per foot, and then the benefit cost ratio, assuming a cost of installing the rumble strips. And so a benefit cost ratio of above 38, a dollar benefit above $131 per foot, therefore it got color coded green. And really what this tool does is it helps our region traffic and safety offices identify, based off of the best methodologies we know of from the Highway Safety Manual, to screen the network, our roadway network, and identify locations where certain safety improvements can be installed that would be expected or projected to mitigate the risks on the roadway and to have the best potential for mitigating crash types such as roadway departure crashes. And so this tool has been very helpful for our region offices in helping to identify potential HSIP projects to submit to us to compete for funding within our HSIP program. And so that's the example I wanted to share today. And I just wanted to show my last slide here, which has my contact information. If you have any questions, feel free to reach out. There's my email address and phone number. And again, I'm Jeff Lewis with UDOT's Traffic and Safety Division. And thank you for your time.